sketch the sine graph, it is based off of the sine coordinates. So, the thing here is I have till pi to here, correct? So I want to see what these all split into. So this would be 1, 2, 3, 4, 5, 6 pieces till I get to pi, right? 6 pieces till I get to pi. So that's 1, 2, 3, 4, 5, 6. So this would be pi divided by 6. 1 pi divided by 6. Then this would be 2 pi divided by 6. What does that reduce to? Pi over 3. And this would be 3 pi divided by 6, which is already there, pi over 2. And this would be 4 pi divided by 6, which is 2 pi over 3. And this is 5 pi over 6, which is reduced. This is 6 pi over 6, which is pi. And I just keep going. 7 pi over 6, 8 pi over 6. What's 8 pi over 6 the same as? So this 2 pi over 6 becomes pi over 3. I'm just going to write it nicely. Then the 3 pi over 6 became pi over 2. 4 pi over 6 became 2 pi over 3. 5 pi over 6. 6 pi over 6 became pi. 7 pi over 6. What does 8 pi over 6 become? 4 pi over 3. 9 pi over 6 takes 3 out of each, so 3 pi over 2. 10 pi over 6, what does that become? 5 pi over 3. 11 pi over 6. And then 12 pi over 6 becomes 2 pi. So I need all the y values that correlate with those x values. So my first one is pi over 6. Pi over 6 is my x. What's my y? My y is sine pi over 6. What's the answer to sine pi over 6? 1 over 2. So at pi over 6, sine of pi over 6 is a half. So at pi over 6, I'm going to go, this is a half, this is 1, this is negative a half, this is 1. So at pi over 6, I'm at a half. What about 0? What was my y at 0? 0. Then I have pi over 3. What is sine of pi over 3? Root 3 over 2, which adds a decimal so that we can actually draw it, is 0.8660. So this would be 0.75 technically, right? So it'd be like here. Then we need pi over 2. What is y at pi over 2? What is sine at pi over 2? 1. Then we have 2 pi over 3. What is sine at 2 pi over 3 on your unit circle? 3 over 2, which equals 0.8660. The same height, a little higher. And then we have 5 pi over 6. What is sine at 5 pi over 6? 1 over 2, a half. What is sine at pi? 0. What about 7 pi over 6? Negative a half. And then we keep going. What about 4 pi over 3? What's sine at 4 pi over 3? Yes, that negative 0.8660. What is it at 3 pi over 2? negative 1. What's sine at 5 pi over 3? Negative 3 over 2. What's sine at 11 pi over 6? And then sine at 2 pi. So we're getting a graph that's going like this. And that's the unit circle, correct? What happens with the unit circle? It just keeps going, same thing over and over and over, right? So then once again, it's just going to keep going that way, and it's just going to keep going this way the same, correct? And it'll just keep going like this forever and ever. So here it says the period is the length of the interval of the domain over which the graph repeats itself. So what's the period of this graph? How long did it take till it repeated itself? So I go past the max, past the min, back up to here. Then it'll keep going and it'll repeat itself, correct? So how long did it take till it repeated itself? 2 pi. Or if it was in degrees, two pi or 360 is what a sine graph does. Amplitude is half the difference between the maximum and minimum. So if I count from min to max, I take half of that. That's the amplitude. So minimum is negative 1. And then I counted up to the top as 1. What's that a distance of? Negative 1 to 1. Distance of 2. What's half of that? 1. So the amplitude for this graph, for my basic sine graph, is 1. If you're given a graph, you can also use this formula. It's the absolute value of the max minus min divided by 2. Amplitude is always positive. We'll talk about that in a second. So in this case, the maximum, it'll be the absolute value of the maximum, which is 1, minus the minimum, which is negative 1, absolute value, divided by 2. So it's the absolute value of 2 divided by 2, which is 1. Amplitude is always positive. That's why those absolute value signs are up there, right? Because even if a negative came out, the absolute value would turn it to positive. So we're going over these for the basic sine theta graph. What was the amplitude of sine theta? That's a sine theta graph. 1. What was the period of it? I don't even know what I just did. I got rid of the page completely. Please, yes. 2 pi. Not 360 because the actual graph was in radians, right? The x-axis tells us if it's in radians or not. So this particular graph would be 2 pi. What's my domain? It's going to go like this. X and L are the reals, yeah. It's going to go on for life. So in set notation, it's the set of x values such that x and L are the reals. In interval notation, it would be negative infinity to positive infinity. What's the range? What's the lowest this graph goes to? Negative 1. What's the highest it goes to? 1. So we have to sandwich it in between negative 1 and 1. So in set notation, that would be y such that we go low to high. So we go negative 1 is less than or equal to y is less than or equal to 1. Do you see how they're the same direction? Inequality signs? It's because you're reading from the y. So y open, so it's open to negative 1. So y is greater than or equal to negative 1, but y is less than or equal to 1. It's because you're reading from the y's, right? And then y is now in the reals with a comma. In interval notation, it's a lot easier. Just square brackets because it's equal to low to high. The graph above, what is your y-intercept at? 0, 0. What do your x-intercepts happen at? X equals 0, what else? Pi, what else? What else? 3 pi, 4 pi, 5 pi, negative pi, negative 2 pi, negative 3 pi, right? So we could write this as a general solution. We can say theta equals, because we want theta intercepts, theta equals, what's our first one?
0.
And when does the next one happen? How much further?
5.
So plus pi n. N is an element of the integers. We start with a 0. Do we actually have to write 0? No, because 0 plus something doesn't change, right? So if you write this as a written response, you're not wrong. The multiple choice answer, though, will be pi n nei. It won't have the 0 plus. Okay, we're going to type this into our calculator. So type this into sine x. And if you want it in degree mode, that's fine. Can everyone follow along, though? Grab your calculator. Yeah. 0 minus pi n? It can be. They won't have that as a multiple choice answer, though. Yeah, they'll always go plus, and then they'll put integers. So the integer part of it makes it have negatives. The old curriculum, they used to go plus or minus, like pi n, but then they would follow behind with n as an element of the whole numbers instead of integers. But they don't do plus or minus anymore. They just do a plus sign. All right, so sine x is in y equals. Then you need to immediately go to your mode and pick a mode. So let's pick degrees. And then I want you to go zoom, trig. Not zoom fit, not zoom standard, zoom trig. And now what it does is it sets that sends that window into degree mode. Okay? Now, if you press graph, you should be able to see it if you press zoom trig, right? It shows up. Now, can everyone listen to me? Don't change anything but the mode. Go mode and go radian. Now press graph. So you just made the mode on your calculator radians, but your window is in what? Your window's in degrees. So you always have to go zoom trig after you pick your mode. So now go zoom trig, and they'll set it in whatever mode you're in, which is radians this time, and they'll draw you the same graph. Do you see the difference? So you always have to pick your mode before you zoom trig. And zoom trig just gets you a window. It doesn't always get you the right window. It just might get it at least in the right mode. Yeah? Go to your y equals, see if you have a sine x in it. Zoom trig. Zoom trig, like I said, do. Yeah, it'll help. Okay, next page. What are we going to draw now? Cos graph. So now the y values of our graph are actually the x's around the circle, correct? Which throws people off because they want it to be y's. So sine is easier because it's the y's. The y's of the cos graph are actually the x values of the coordinates around the outside. So for example, let's relabel these. So this would be pi. This would be pi over 6. This would be 2 pi over 6, which is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6. 10 pi over 6 is 5 pi over 3. 11 pi over 6. And then 12 pi over 6, which is 2 pi. So, wait till you write this down. When theta is 0 on the unit circle, what is cos of 0? What is cos of 0 on your unit circle? 1. So this one actually so we're at 0, 1. And if I do pi over 6, what's cosine pi over 6? Root 3 over 2, which we know is 0.8660. So it's like here. What is cosine pi over 3? 1 over 2, 0.5. And we have pi over 2. What's cosine pi over 2? 0. So you see how our y values on cos are actually coming from the x values, which I know is confusing. It's not my first rodeo with confusing people with it. So you remember, you just have to say cos of it. So what's cos of 2 pi over 3? Negative a half. Then what's cos of 5 pi over 6? Negative root 3 over 2, or negative 0.866. What's cosine pi? Negative 1. Right? And we keep going. What's cosine 7 pi over 6? What's cos of 7 pi over 6? Negative root 3 over 2. What's cos of 4 pi over 3? Negative a half. What's cos at 3 pi over 2? What's cos of 3 pi over 2? 0. What's cos at 5 pi over 3? 1 half. Yeah, and then cos 11 pi over 6? 3 over 2. And then cos of 2 pi? So you're seeing a pattern. So here we're going from a max to a min, back up to a max, and then after that, what's it going to do? Repeat itself, correct? So I want you guys to try and fill this in. Go. Okay, what is the amplitude of this graph? 1. Because we can use the formula if we want to. Absolute value of the max, which is 1, minus the min, which is negative 1, divided by 2, which is 2 divided by 2, which is 1. Or we can count the vertical distance and divide it by 2, right? What's the domain? X, such that x and L in the reals for set notation. Interval would be negative infinity to positive infinity. Y-intercept, this one's not 0, 0, it's 0, 1. What's the period of this graph? How long does it take to repeat itself? 2 pi, a unit circle. The range? Y such that negative 1 is less than or equal to y is less than or equal to 1. Y is now in the reals. Negative 1 to 1. And the intercepts are at pi over 2 and 3 pi over 2. How far apart is that? Pi over 2 and 3 pi over 2. How far apart is pi over 2 and 3 pi over 2? Half the circle, which is pi. So we'll go theta equals pi over 2 plus pi n. N is an element of the infinite. And then once again, you could technically put that in. Okay, amplitude and period of any sine function. As discussed earlier, the amplitude could be the max minus min divided by 2. However, that's from a graph. If it's from an equation, it's just the absolute value of the A, whatever number's in front. So the absolute value of A is the amplitude. So if you're from a graph, you're going to use this formula. From an equation, it equals the absolute value of A. Okay? And the reason why that is the absolute value of A is your vertical stretch factor. So you're normally one apart. If I stretch it higher, it'll make the amplitude change. If I stretch it lower, it'll make the amplitude change. All right. And then the period from an equation is 2 pi divided by the absolute value of B. And the reason why you divide by B is because the only thing that can change it is the horizontal stretch factor. So if my graph went like this, and it stretched it by 2 pi, if I had a horizontal stretch by 4, what would it now become? 8 pi. Okay? So remember, your horizontal stretch factor is not B. What's your horizontal stretch factor?
A.
Nope. A is your vertical stretch. Horizontal is not B. What is it? 1 over B. Remember, your horizontal stretch flips. Yeah, the reciprocal. Or you can use the formulas. Oh wait, let's look here. State the period and amplitude. So what's my amplitude for A? It's 2. Your amplitude is actually the vertical stretch. Remember, if this was negative 2, it would still be 2 because the negative is the reflection. I was trying to tell Jonas to hit you, but he didn't listen very well. He was not catching it. Yeah. Sleepy Sleeperton? Yeah. Okay, good. He's awake. All right. The period, let's just use 360 for now. It would have to say if it's in radians or degrees because it doesn't really tell you here. But say I use 360. The period is normally 360. We agree? If the horizontal stretch factor is bigger, like 2, it's going to become 720. If the horizontal stretch factor was a half, this would become 180. Correct? It would be half of that. So what is my horizontal stretch factor here? My vertical stretch is 2. My horizontal stretch is 1 over 3. It flips. So what's 360 times 1/3? It's the same as 360 divided by 3. 120 degrees. So if your B value is actually greater than 1, your period's going to shrink. Because your B, remember, isn't the horizontal stretch? 1 over B is. What's the amplitude of this one? What's the amplitude of B? 1/2. My B value is a half, so is the period going to get bigger or smaller than 360? It's going to get bigger. So we do period equals 360 degrees times my horizontal stretch factor. What's my horizontal stretch factor? 2. So it's 720. All right. So for this one, you're going to state the transformations. We're not going to do anything else right now. I just want you to state transformations. So for example, number 1, when I have a 2 in front, that is a vertical stretch by a factor of what? 2. Remember, vertical stuff never switches. All the y stuff stays the same. About the what? X-axis. And then I want the mapping because we're practicing. X, y becomes what? Remember, words and mapping are in a heart. Nothing affected my X, and what's going to happen to my Y? 2y. Okay? This is going to be a horizontal stretch by a factor of 1/3. Yeah? Go, do them all. 1, 4, I don't know why that's 1, then 4, 5. You're welcome. Look, that was short because there's no 2, 3. I don't know where they went. Here we have a horizontal stretch by a factor of what? 1/3 above B. So we get xy becomes 1/3 x comma y. This one is a horizontal stretch by a factor of about B. Okay, keep in mind I'm not giving you any more class time for the hand, and tomorrow we're going to do some review on trig, and then we're going to move on to this, because we're going to finish up chapter 5 before the break. So when we come back, we're starting exponentials and logs, and we'll have a cumulative somewhere in there. So after the break, when we come back, we have 5 units left. We have exponents, logs, radicals, rationals, and other functions. Well, radicals is 2 lessons, rationals is 3 lessons, other functions is 3 lessons. So those 3 units come together as 8 lessons. Logs and exponentials are the long ones.
How many units have you done so far?
You've done terms and comps, transformations, polynomials, chapter 4, chapter 6. So you've done 5, but those are legit 5.
Yeah.
The 3 that are together for 8 lessons, I would consist as 1 unit.
Yeah.